Hey everyone, and welcome. Today, we are diving deep into simple interest. But we're not just talking about the basics. We're tackling those tricky exam questions that always seem to eat up way too much of your time. By the end of this, you're going to have the shortcuts to solve them in just a few seconds. So let's get right into it.
You know the feeling, right? You see a simple interest question on an exam and you just know it's going to be a time sink. But what if I told you that you could solve these problems in a tiny fraction of the time you're used to? Well, that's exactly what we're going to do today by learning a few really powerful time-saving tricks.
So here's our game plan for today. We're going to break down 4 of the most common question types you'll see on your exams, one by one. And then we'll wrap it all up with a super fast revision to make sure these tricks really stick. Let's jump right into our first type. All right, let's start with type 1, ratio problems. This is a classic exam pattern where a sum of money gets split into 2 parts, and the simple interest you earn on both of those parts happens to be exactly the same. And here is the secret sauce, the shortcut that saves you a ton of time. Whenever the simple interest is equal, the ratio of the 2 principals is just the inverse ratio of their rate multiplied by time. The formula is right there on your screen. Seriously, this is the key to solving these questions almost instantly.
Let's put this trick into action with a real question. So, a sum is divided. The simple interest on the first part at 8% for 3 years is equal to the simple interest on the second part at 2% for 8 years. All we need to do is find the ratio of the 2 parts.
Okay, so according to our inverse formula, we need R2 times T2 up top in the numerator. So for that second part, we have a rate of 2% and a time of 8 years, which gives us 16.
And now for the bottom part, the denominator. That's R1 times T1. The first part had a rate of 8% for 3 years. You multiply those and you get 24.
So the ratio of P1 to P2 is simply 16 over 24. We just simplify that fraction and we get 2 over 3. And just like that, using the formula, we have our answer in seconds. That's option B.
All right, let's keep the momentum going and move on to our second type. These are what I call the n times questions. You've seen them, where you're asked how long it takes for a sum of money to double, triple, or become, n times its original value.
And of course, there's a direct formula for this too. The logic is actually pretty simple. If your money doubles, so it becomes 2 times, the interest you've earned is 1 time the principal. If it triples, the interest is 2 times the principal. The interest is always just n1. This formula helps you find the rate needed to get there in a specific amount of time.
Let's look at an example. A sum of money becomes 4 times itself in 5 years. We need to find the rate of interest per year. So, how do we use our new formula here?
Easy. Here, n is 4, because the sum becomes 4 times itself, and t is 5 years. We just plug those into the formula. We get 4 minus 1, which is 3, divided by 5, and then multiply by 100. A quick calculation, and we get 60%. Option C is the correct one. See how simple that was?
Now on to type 3, changing interest rates. These can look a little intimidating because the interest rate isn't the same for the whole loan period. But don't you worry, there's a really straightforward way to handle this as well.
The logic here is super simple. All you have to do is calculate the total interest percentage for each little time period separately, and then you just add them all up. This gives you the total effective interest percentage for the whole duration.
So check out this question. The rate is 3% for the first 2 years, then it jumps to 8% for the next 3 years, and then it's 10% for any time beyond 5 years. Someone gets 10,640 rupees after 6 years. We've got to find the original sum they deposited, the principal.
Let's calculate the total interest percentage step by step. So for the first 2 years, it's 3% times 2, that's 6%. For the next 3 years, it's 8% times 3, that's 24%. Okay, that's 5 years accounted for. We need the total for 6 years, so we have 1 year left. The rate for that last year is 10%, giving us another 10%. Add them all up, 6 plus 24 plus 10, that gives us a total interest of 40%.
And here is the final step. We always think of the principal as being 100%. The total amount is just the principal plus the interest. So that's 100% plus our 40% interest, which equals 140%. Now, if 140% is equal to 10,640, we can easily calculate that 100%, our original principal, is 7,600 rupees. That makes option B our answer.
And now we've reached our final type, mixed or advanced questions. These problems are designed to really test your core understanding by mixing a few concepts together. But let's see how to crack them.
Okay, here's the question. A sum amounts to $9,000 in 5 years, and that same sum grows to $12,000 in 8 years. We need to find the rate of interest. Notice what's different here. They haven't given us the principal or the rate to start with.
The absolute key to solving this is right here. Just look at the difference. The time difference is 3 years, right? And in those 3 years, the amount grew from 9,000 to 12,000. That's an increase of 3,000 rupees. And because this is simple interest, that increase is the interest that was earned. So the interest for 3 years is 3,000 rupees.
So, if the interest for 3 years is $3,000, then the interest for 1 year is obviously 1,000 rupees. Now we can work backwards to find the principal. We know the total amount after 5 years was 9,000. This amount includes 5 years of interest. So the principal is just 9,000 minus the interest for 5 years, which is 5,000. And that gives us a principal of 4,000 rupees.
We're in the home stretch. We have everything we need now. The interest for 1 year is 1,000, and the principal is 4,000. Let's just use the basic rate formula, SI divided by principal times 100. That's 1,000 over 4,000 times 100, which gives us 25%. Option C is correct.
Excellent work. We have now covered all 4 of these major patterns. Let's just do a super quick revision to make sure these tricks are locked and loaded in your memory for exam day. Here it is, your final summary sheet. I would seriously recommend taking a screenshot of this for your notes. When SI is equal, the ratio is inverse. When a sum becomes n times, use the n-1 over t formula. When rates are changing, you just sum up the rate times time for each period. And when you're given amounts at 2 different times, find the interest per year from the difference.
And there you have it, some really powerful tricks for simple interest. I really hope these help you absolutely ace your exam questions. Now, what math topic should we master in our next explainer? Let us know in the comments below. And if you found this helpful, please